Hello, and apologies for not doing this sooner. Tomorrow is the big day for core maths studies for paper one. I'm going to do a quick walkthrough of the November 2021 paper. Hopefully, I can get this all done within the time allowed. So let's start off with, and we'll see how many questions I can do before I have to cut off. So I'll try and do these in batches. So we've got here question one. Ismail records the animals he sees on a safari, which word does not describe the type of data he collects. So qualitative raw data, yeah, he's gone to go get it. So raw, qualitative, records the animals he sees, that's good. Primary research, good. So continuous is the one, so we circle that. Okay, fantastic. So I've not read this paper beforehand either, so I might have to panic a little bit when we go to the prelim material. James and Kia are doing a survey about how people travel to work. James asks 10 people at the bus stop one morning. Kia asks 40 people, chosen at random, in the town centre every day for a week. Make two comparisons of their methods of collecting data. So James may have bias. As the people at the bus stop are likely to catch the bus. Of course they are. Because if they had a car, I don't know why they'd be at the bus stop on the morning going to work. Second thing is Kia's data is more reliable as they have a greater I want to say sample group. It's basically they've asked more people, so it's more reliable. The more people you ask, the better, more reliable it is. So anyway, that's not the only answers. I've just got the mark scheme open. So we've got James's sample size is too small, or Kia's sample size is better. James's method is more biased, as all at the bus stop. I've nailed I've got the first two reasons there, which is great. Kia's method is better as she uses more than one day. So what have we got there? Yeah, every day for a week. That's decent. Kia asked 40 people, so actually she's probably going to end up asking 40 times 7, so that's 280 people. James' method is quicker and cheaper, so that's good. And then Kia's method uses random sampling, whereas James' method is more of a cluster sample because he's going to that particular place. Okay, fantastic. So that's 2A done. 2B, get my calculator out. I can see some numbers now. Amy is also doing a survey about travel. She collects this information about how teachers travel to her school. Amy wants to ask some of the teachers more questions about travel. She decides to ask a sample of 30 of these teachers, stratified by type of sample of transport. Work out how many teachers she should ask from each group. Well, that's fine. So we're going to shrink this down so that the total equals 30. Let me just add these up. I've had such a bad day today getting things wrong. I'm using the calculator for everything. So this equals 130. So car, bus, and walk, we need to do 84 out of 130 times by 30. So that's going to be the amount. And we're just breaking this down into like the proportion within those groups. And if we multiply it by 30, we'll get some numbers that we can then fit into that sample size that we want. So times by 30, that first one, right, that gives me 19.38. Going to add it to two decimal places to begin with. I feel these numbers would be better suited if they were like divisible by 120, but I've definitely added up correctly, so there's no problems here. And then 1 over 13, take a shortcut, times by 30, it's 2.3. Okay, so if I do these, they're not actually all going to add up. So I'm probably going to put this one to 20, this one to 8, and that one to 2, because I can't just ask point something of a person. All right, so let's check the mark scheme and see if they're okay with me rounding it up. Do you know what? Oh, they've given so many options. So I've gone for 28 and 2, which is the first choice. They then allow 19, 8 and 3 or 19, 9, 2. So you can add that extra one on wherever you go. And this bit in here is where you get the like workings mark. So make sure you're showing your working as you go. Okay, super. Oh, and there's an answer box to put them in. That's convenient. All right, that's question 2 done. I think I've got loads of time. We'll get question 3 done. Don't need to use the preliminary material yet. That's great. The table shows information about the annual salaries of 80 people working in sales in the UK. On the grid, draw the cumulative frequency graph. Okay, so we're just adding these as we go. So 9 plus 36 is 45. So we've got 9, 45. Add that 21 to get 66. Add the 8 because it's cumulative frequency. So we are accumulating the numbers as we go. 78 and then 80. I've got 80. I just want to check. It does say 80 in the question as well, so we can check if we've done that right. Right, zoom out a little bit because for cumulative frequency, we need to draw these. Oop. We have to draw them at the end of the boundaries. So that's at 9. The next one's 45. We then go to 66. Just a little check as well to make sure that these boundaries are even, and they are, so that's fine. 74 at the next one, 72, 74, 78, and then 80. So, and then it's a freehand drawing, hitting as many as we can, lovely. And then yours will be more accurate because you've got pen and pencil. You have to do it on a screen. So there we go. There's my cumulative frequency graph. I'm really happy with that. Use your graph to estimate the value needed to complete the sentence below. 20% of these people earn less than. So we've got 80 people, times it by 0.2, and that's 16. So 16 people are inside of that 20% bit. Okay, so 16, we've got 10, 12, 14, 16 is there. My line will go down into that bit there. So that reads 13,000 for me. 13,000. I'm just going to have a little look at the mark scheme because there's going to be a nice variation for you. Correct reading for cumulative frequency of 16 from their increasing graph. And it says allow 11,900 to 11,944 from interpolation. Okay, I've not done that. I've used the graph from interpolation. And actually, oops, a daisy, go back up. They don't give an exact correct answer here. So it does say correct follow-through reading for their 16 for an increasing graph. And then the actual answer, correct reading for cumulative frequency of 60 from their increasing graph. So as long as you've done your graph bit fine, you'll get 2 marks. If your graph's a bit wrong, but you've read it off properly anyway, then you're okay. And then actually this bit here is worth 1 mark. This bit here is worth 1 mark. So if you don't get it right, you're still going to pick up something. The average salary for all people working in sales in the UK is approximately 22,000. Estimate the percentage of these 80 people who earn more than the average salary. So the average salary for all people working in the UK sales is approximately estimate the percentage of these 80 people who earn more than the average salary. So we need to know how many people earn more than 22,000 roughly. So that's going to be the second line from here. You will obviously use a ruler. For me, that's perfect. Look at that. It's on the line, which is brilliant. And I come over and I've got 50. Right, 50. So that means 30 people are above that line. So 30 out of 80. And then I need to times that by 100 to get to my percentage. And that gives me 37.5% people are above. And again, the mark scheme says something between 37, 38. They are looking for you to be accurate with your graph. So the poor markers will have to take ages working all of this out. But that's what they're paid for. Right, question 4. Oh, hello. Right, let me just quickly look at how long I've got left on here. It's telling me we've got 5.5 minutes, which is fine. So we can do this question and we're done. Estimate the number of school meals served each year in a large secondary school. Well, luckily enough, I work in a large secondary school. So I reckon 300 kids per year group, 300 kids per year group, times by 5, 1,800. So my assumptions is that there's 1,800 in the school, and there might be a sixth form, but I'm going to ignore that because it says a large secondary school. So there's that many in the school. I'm going to say that 60% have school meals because lots of people bring their food in. I'm going to go with 60% school meals. And then I'm going to say that there's 39 weeks in the year. And it's 5 days per week. Now, of course, some kids will be off, but I'm thinking my 60% of the school meals will sort that out. So we've got 1,800. That's the amount of pupils. Times it by 0.6. Now that's going to give me the percentage of, or the amount of kids that will have the school meals. Then once I've done that I'll do that now. Let's do it steadily. 1800 times by 0.6 gives me 1080 pupils. 1080 times by 39 weeks. And then times that by 5 because there's 5 days in the week, which is 210,600 meals per week. So I'm happy with that. Let me check the mark scheme. Again, I've not looked at any of this before we've done it. Makes an assumption about the number of pupils. So correct, 1 mark. Makes an assumption about the proportion that have school meals. I must be good at my maths here because I'm getting all these right. Makes an assumption about the number of school days. So there we go. That's in there, these 2 bits. Works out their percentage times by, so that's the amount of kids times by the percentage times by the school days. And then if you've got an accurate answer, you're in for 5 marks. Super. Okay, I hope you've enjoyed that. Good luck tomorrow. I'm going to try and make another video. I've got a lot of tutoring to do tonight, but I'll try and get that all done and ready for you so that you can have a look at it at least tonight. But if I don't get the other one done, forgive me. But good luck. Spread the word, and I will make sure I get a paper 2 done. Best of luck. See you soon. Bye-bye.